The immutable ledger, demystifying blockchain. Hey everyone, and welcome back to the Y Machine. Today, we're diving deep into a concept that's revolutionizing industries and challenging our traditional understanding of trust. Blockchain. Ever wondered how we could create a system where transactions are transparent, unchangeable, and don't rely on a single authority? Get ready, because we're about to demystify the magic behind this groundbreaking technology. The problem with centralized trust. Let's imagine a bustling digital marketplace where countless transactions happen every second. Every time you buy something online, send money to a friend, or even just log into your banking app, you're trusting a central authority, a bank, a credit card company, or a social media platform, to manage and verify that interaction. Now, imagine this. Sarah wants to send money to her friend Mark. She uses her banking app, and the transaction goes through. But what if the bank's servers crash? What if there's a data breach? What if a third party interferes, or daily transfer limits halt her transaction? Suddenly, that seemingly simple act becomes a precarious dance of reliance on a single, vulnerable point of control. This centralized system, while familiar, introduces potential for delays, errors, and security risks. Enter the digital revolution, cryptocurrency and blockchain. To tackle these challenges, a revolutionary idea emerged: cryptocurrency. These digital or virtual currencies are built on a foundational technology called blockchain. Think of blockchain as the ultimate digital fortress. It's incredibly resistant to tampering, doesn't need a central power to operate, and is secured by layers of sophisticated encryption. While there are thousands of cryptocurrencies out there, from Litecoin to Ethereum, the one that truly pioneered this space is Bitcoin, building the chain, a transparent record. Let's illustrate how blockchain works with a simple scenario. Imagine 4 colleagues: Alice, Ben, Carol, and David. Alice owes Ben 2 bitcoins, Carol owes Ben 2 bitcoins, and David owes Ben 2 bitcoins. Let's assume Ben has 5 bitcoins, while Alice, Carol, and David each have 3. First, Alice sends 2 bitcoins to Ben. This transaction isn't just a fleeting event. It's meticulously recorded. A block is created, containing the details of Alice's transfer and the updated balance for both Alice and Ben. So now, Ben has 7 bitcoins, and Alice has 1. Next, Carol sends 2 bitcoins to Ben, and then David sends 2 bitcoins to Ben. Each of these transactions generates a new block. These new blocks don't just stand alone, they link back to the previous block, referencing the balances from the transaction before it. It's like a digital paper trail, each page physically connected to the last. This interconnected sequence of records is what we call a chain of blocks, or a blockchain. Crucially, every participant in this network holds an identical copy of this entire chain. This is known as a public distributed ledger. Immutability and security. Why blockchain is unhackable. So, what happens if David, with only 1 bitcoin left, tries to send 2 bitcoins to Ben? The transaction simply won't go through. Why? Because every single person in the network has a copy of the ledger, and they can all see that David only has 1 bitcoin remaining. They would immediately flag David's attempt as invalid. This distributed nature is blockchain's superpower. A hacker can't simply alter data within a block. To do so, they would have to simultaneously change every single copy of the ledger held by every single person in the network. An incredibly complex and virtually impossible task. Furthermore, the data within each block is secured by advanced cryptographic algorithms, making it incredibly difficult to manipulate. Simply put, blockchain is a continuously growing list of records, called blocks, which are linked and secured using cryptography, making them exceptionally resistant to alteration. The anatomy of a Bitcoin transaction. Let's peek under the hood of how a Bitcoin transaction between Alice and Ben actually works. Every user in the Bitcoin network has 2 unique cryptographic keys. Public key. Think of this as your public address, like an email address. Everyone knows it, and it's where people can send you cryptocurrencies. Private key. This is your secret password, known only to you. It's what allows you to authorize and digitally sign your transactions. When Alice wants to send bitcoins to Ben, she initiates the transaction. She inputs the amount she wants to send, along with her and Ben's unique wallet addresses. These details are then run through a hashing algorithm. Bitcoin uses SHA-256. The output, which is a unique string of characters, is then encrypted using Alice's private key. This digital signature proves that the transaction originated from Alice. This encrypted message, along with Ben's public key, is then broadcast across the entire Bitcoin network. Only Ben, with his corresponding private key, can decrypt and access the Bitcoins. Different cryptocurrencies use different hashing algorithms. For example, Ethereum, another prominent cryptocurrency, uses Ethash, mining, the engine of the blockchain. These transactions, like Alice's and Ben's, are happening constantly around the globe. But how do they get added to the blockchain? This is where miners come in. Miners are powerful computers that dedicate their processing power to validating these transactions. To add a new block of validated transactions to the blockchain, a miner must solve a complex mathematical puzzle. The first miner to successfully solve this puzzle gets to add the new block to the chain and, as a reward for their effort, receives a certain amount of new bitcoins, currently 25 bitcoins per block. This process of solving the mathematical problem is called proof of work, and the act of adding a new block to the blockchain is known as mining. Once a block is mined and added, Alice and Ben's wallets are updated, along with every other participant in the network. The future is decentralized. Blockchain is more than just a technology for digital money. It's a paradigm shift towards a more transparent, secure, and decentralized future. From supply chain management to digital identity, its potential applications are vast and transformative. What are your thoughts on blockchain? Do you think it's the future of transactions? Let us know in the comments below. If you found this explanation helpful, please give this video a like, share it with anyone curious about blockchain, and don't forget to subscribe to The Why Machine for more deep dives into the concepts shaping our world. See you next time.